Hey guys, how's everything going? This is Jace here. This is another video of my YouTube series React source code walkthrough. It's episode 21. This video is about lanes in React. In the previous video, I've covered how React scheduler works, right? It schedules tasks depending on their priority, and internally they just use expiration time to determine which task should be run sooner. That is scheduler priority. But speaking of the React reconciliation, we know that React holds an internal fiber tree structure to represent the current state of the whole web app. And for each task in the scheduler, we know that what is scheduled is actually just a purely re-render, right? It doesn't identify which fiber to re-render. It just re-render the whole tree, and it's the reconciler's job to keep track of the last, to handle the job work interruption and resuming. So that leads us to a question. For the fiber tree, for each fiber, there are a lot of jobs, a lot of works. React concurrent mode actually supports this lane structure to identify the priority in different work. So there are actually three priority systems in React. If we take a look at the ensure root is scheduled, which is one of the most important functions of React internals. You can see the logic here. We first get the callback priority, which is the scheduled priority to be set to get from the lanes. We will cover lanes later. To get to the highest priority lanes, and then if this callback is sync lane, then we just do something. If it is not sync lane, we will map. You can see we will map the lanes to event priority. Then we, based on the event priority, we would decide the scheduler priority, and then schedule the scheduler priority to this callback, which is actually basically re-render. So there are three series systems. One is scheduled priority, we've already covered. The other priority is event priority. The event priority sounds straightforward. It's like when user interact with your web app, where there might be a lot of events, right? Like a click, mouse over, hover, any kinds of event. Those events have actually, the React thoughts it has some priorities. Yeah, it's reasonable. Because like for events for message, I see the source code. Like for message, it's actually the event priority depends on the current event priority. Anyway, the priority is there, and also the lane priority. It's to mark the priority of small pieces of work. We have these three priority system, but internally they have some like a mapping logic. Like here, lanes. There are more lanes priority than the events priority. And the scheduled priority, I think this is to decouple the priorities inside of React, and these are just some maybe raw logic right now. They maybe improve the logic for future, so that's why they are not using single priority. That's just one priority system right now. I think it's for the future. So what is lane? One of my videos talk about set state. I've put a link here. If you're interested, you take a look. There's actually a diagram link there. You can take a look. So in set states, we've already know that when it is called, it actually creates an update on the hook. So for a fiber, it has a linked list of hooks, and for each hook, it has this linked list of updates. That's what is under the hood of set state. So in the updates, we can see two lines of code here. First, we request update lane for this fiber, and then set the lane to this update. So this is the first time actually we've directly touched the lane field. Yeah. So lane here is to mark the priority of the update, which we can also mark the priority of a piece of work. And this lane is actually just numbers. It's just called lanes because it's choose the numbers which could be perfectly represented in a binary form with only one digit of 1. You can see that it actually has 31 lanes. And then each lane is just 1. the here is just a group of lanes, so it's lanes. So it's just a number. You can see that lane. It means, yeah, it's just a simply bit mask. The sync lane, which is the most important lane, is the smallest. So the smaller the lane is, the higher priority it has. It's straightforward, right? If you are driving on the highway, you should drive on the lanes depending on your speed. If you are driving fast, then you should go to the fast lane, right? A surpass lane. If you're not driving slowly, you just drive keep to the left or right to the default lane. That's it. So there are a lot of lanes. We're not going to cover all of them. In this episode, we'll just try to explain generally what lane is and how it works. Okay, because it's some binary forms, we must get familiar with some bitwise operation here. Like if you're going to decide if some lanes are included in some lanes, then we just use this and here. And if and means that if both of them needs to be 1, right? So if the result of this is not 0, then there's some lanes must be included. And also we could use the or, stuff like that. Also, in a previous video about how React bailout, there's a link here. You can take a look. It also touches the child lanes. It's also related to lanes. We see here that actually React, when we set an update to a fiber, it actually marks all the fibers, the parent, the ancestor nodes, to let it have the information of its lanes in the children. So if it is updated here, then all the nodes here will have the specific lane, its child lanes in its priority. So in all, for each fiber, it will have a lanes priority containing the updates of itself, and also it contains a field called child lanes, which contains all the work, all the depending lanes of its descendant fiber, which is pretty straightforward, because if you want to know what needs to be done, you don't need to just traverse through all the fiber tree to get the information. You just now only need to take a look at the root node and just get the child lanes information, and you know what kind of work we need to process. This is important. And then let's go back to perform concurrent work on root again. This is, basically just to say, okay, do your best to re-render and avoid unnecessary work as much as you can. But just do it. So here is basically a flow of how the work is scheduled and run. We've already covered in this previous post. If you are not familiar, refer to my blog. The first one, as we covered in the beginning of this post, we get the next length of the fiber tree, which means the descendant nodes, right? The work of descendant nodes, and then map it to schedule priority. And the scheduler will schedule the task to reconcile. The task is to the perform concurrent root, and then it is called by scheduler, and the work begins. And But in this process, we don't see the real use of this length info, right? It must be hiding in this step 4. Let's take a look. Okay, so in this function, perform concurrent work on root, we see a few lines here. The first one is get next lanes. This obviously is to say, okay, get some lanes we're going to work on. There might be multiple lanes. Just give me the highest priority one, and then prepare a fresh stack. Prepare fresh stack, as the name implies, it will rerun the re-rendering from fresh. So remember, we say concurrent mode is cool because it actually allows interruption. Say if you have done reconcile like half of the tree nodes, and then you interrupt and you can resume just from the last state. But prepare fresh stack is just to redo it all over again. It's specifically for initial rendering and also for some edge cases, like some fatal error happens. You don't know what the work, finished work, interrupted work cannot be trusted again. Then we just redo it all over again. This is why React say React has the right to re-render your application anytime, like from the sandbox, from the black box. You don't know. Okay, so in this prepare fresh stack, it's pretty simple. It's just update, initialize some global variable. I don't like this in React because it's just so much global variables. It's hard to understand what is going on. But anyway, inside of these variables, we have a few variables which has the postfix of lanes. You can see work in progress render lane, subtrue render lane, work in progress root include, blah blah blah. We don't need to know all of them right now. I don't know what all of them. But work in progress root lanes looks simple, and let's just focus on that. It looks like the variable to keep track of the work in progress lanes, right? Okay, the lanes are rendering. Cool. So in the request update lane, we have seen the usage of this global variable. It says, okay, remember request update lane? It's used in this update creation here. When we set update, when we create an update by the set state, we will request update lane. Say, which lane we need to put this update. Inside of it, there's a lot of logic here. I'll skip it because I don't know much of them. But anyway, you can see that somehow, if it is still work in progress, then we need to pick some lanes in this work progress lane. It sounds straightforward, right? Yeah, yeah. There's the comment here. You can see it. But our goal in today is not to understand the logic here. Let's skip it. So anyway, it's kind of the deviated from our topic. Let's go back to our original function. Perform concurrent work on root. Okay, lanes get next lane. Okay, yeah, use the field store, determine the next lane to work on. Just gets the highest priority lane. And then if say there's no lanes to work on, then there's nothing to worry about, right? Because there's no work to work. So we return now, ended. And something interesting part here, even though we're in the work in progress even we are in the perform concurrent work on root, which should be the concurrent mode, but there is an internal check about whether we should use time slice. This is an old name. I think we should rename it. It's like concurrent mode or something. Should time slice? Okay, there's some logic there. We've already covered like the timeout, right? Last time in the scheduler. If it's timeout, we need to do the synchronous rendering. But also there are some checks about lanes. You see, include blocking lane. Say, okay, if something needs blocking, then we should not. Yeah, here you can see the exclamation mark here. We should not use the time slicing. Yeah, based on these conditions, if we should not use concurrent mode, then we just use the root async mode. Otherwise, we use concurrent mode. Yeah, so this is this is it. And but still, we don't see the exact usage of the lanes, right? No worries. We go to set the details of use state. I've already covered use state in the previous episode or blogs. You refer to that. Here, we just jump to the source code. Upstate internally used up to reducer. Internally, blah blah blah. You can see that. Okay, gets the hook. Current, creator queue, blah blah blah. Update state. This is not the initial render for re-rendering. For update reducer, it needs to run the updates we scheduled and gets the newest data, right? So the update reducer, it should run the necessary updates. So we can see the code here, a long list, but we skipped it. We just focus on the raw structure. We can summarize into this one. So we get to the lane and go to keep a for loop, a while loop, to loop through all the lane updates, because updates is connected into a linked list. You can see that here is subset of lanes, render lanes, update lane. It means if this update needs to be run in this render, in this path, so render lanes here. If not, it says priority is insufficient. We should not do it, right? But if it is, we should run it. So here is actually, you see, we check the lane info. Update lane against this render lane. And where is this render lane comes from? We just go trace the function callback calls. You can see that it traces back to perform unit of work. And in it actually, it's okay. Yeah, it's begin work, current unit of work, subtree render lanes. Yeah, that's it. So you can see that the idea is we schedule a lot of updates on any fiber, but each update had its own lanes. And when we are scheduled, say, re-render the whole fiber tree, we pick the highest lengths to map it to scheduler and then schedule the task. And when we go back to really do the job, we would choose the highest lengths and work on them. It means that not all the updates will be run at the same time. So summary, yeah, I've summarized it, and take a look. So you might wonder, it sounds interesting. So what's the real point of using lengths? Let's just jump into some example here. The first demo, I believe you've already seen it. It's from the official. Like when I type something, type A, you can see that's very laggy. The input is not responding. Why? Because if you take a look at our code, we only use one state here, tags, and this tag is used in this input and also used in the cells. But in the cells, we forced some delay in the rendering, blocking the main thread. And this results in that the updates of the cells and updates of the input are all scheduled in the same lane, right? The same lane. And of course, the update here will be blocked by the cells here, so it will be laggy. So what we can do is to separate them. Here is the second demo. You can see it with type of A again. You can see that here is already updated, but for cells, it's not. It's lag. It will wait for the update about input, and here is done, right? So how did we do that? You can see the source code. We use this method from the React built-in. It's called use deferred value. Actually, I've already had a video on my YouTube channel about how it works internally. So if you're interested, go to my channel and find it out. So generally speaking, this deferred text will use deferred value will move the lane to the transition lane. As we already see here, there are a lot of transition lanes, right? Here, there are 16 transition lanes. It use one of them. So transition lanes is different lanes from the sync lane. As we said, the re-render will pick the highest lanes, which is the input here. And then after it's done, we'll go to the next lane. If we open the console here, this is the first one, you would see it better. Like say when I type A, you can see that there's only one lane scheduled, right? Pending lane is just one, and then we work on sync on root, work on sync. Perform, and then they're all rendered. But if we go to here, when we type something, you can see that it's a bit different. Pending lane is this default for the input. It's sync lane, and it's no worries. But also you schedule another lanes here. Is one here. They are not scheduled at the same time. There's because this is I think it's something inside of the use deferred value. If you're interested, please figure it out in based on my video or something. But anyway, the idea is that you can see that we schedule different lanes of work, one for the high priority, one for the low priority, and then that's why we can achieve this time slicing feature. Okay. So I have another demo, which is very interesting, I think. I've tried to expose the internal method in my demo. And the source code is pretty simple. You can see I have a created state, and then okay, this there's a typo here. It should be 0. And then when the button is clicked, I first set update priority to 4. This will say, okay, for the next update, you should set the lane to 4, which is input continuous lane. And then inside this update, it increments the number by 1. I realized that there's a typo here. Don't ignore me. It should be a number here. I'll update in the blog post. And then again, we set the priority to 1, which is sync lane, and then times the number by 10. So, and then I'll log all the numbers in each render. So what would you expect? The default is 1. Default is 1. When I click it, what should you expect? You might think that if we don't take the priorities into consideration, we know that even if we set a state to like this, it will just run in the same time. So you might think it will be, okay, 1 plus 1, 2, 2 plus 2 times 10 is 20. So it should be 20, right? Okay, click me. No, it's 10, 20. Why? Because this update scheduled here has high priority, it will be run first. And then it says, it means that 1 times 10 is 10. And then when it is done, it will go to priority 4 and then plus 1. But notice that these orders, it's just the order. It doesn't mean that they are exclusive to each other. So when the priority is, the update here will still be run in the next pass. So, but internally they have this kind of memoir state, so it actually will not be run because of this performance improvement. But you can think of it, they will be run again from the outside. So it's plus 1, 2 times 10, 20. So there are 2 renders, 10, 20. So yeah, that's it. If we go to the console log, you will see this time we schedule the work at the same time. We will result in sync lane and input continuous lane, but we will still work on sync lane first and then render with 10 and then continuous lane later and 20. So that's it. That's lanes. Pretty interesting, huh? I think it's great. Yeah. Stay tuned for my next video. Hope it helps. Happy coding. Bye bye.